Good afternoon, class. Today we're going to be looking at assignment number 17, piecewise and quadratic functions. And let me switch over. I need to do a little writing first. We'll start off, what do we mean by piecewise function? I'll start off with my green pen since it's St. Patrick's Day. A piecewise function, P-I-E, piecewise function is a function that's defined using two or more algebraic expressions. It's not just y equals 3x minus 7. There are two or more algebraic expressions. We're going to do two things with regards to piecewise functions. We're going to evaluate piecewise functions using function notation, and we're going to graph piecewise functions. The evaluating piecewise functions, that's pretty painless. Evaluating piecewise functions. And let's look at number 2. And okay, I'm going to be using different colors for each piece. Notice this function has 3 pieces: the negative 5x minus 10, the constant function 1, and x plus 5. There are 3 pieces. I'll write each piece in a different color that hopefully you'll be able to tell the difference. I know some of these, sometimes the colored ink all looks the same color, but here we go. H of x equals, there are 3 pieces. Let me write down the first piece, negative 5x minus 10. You'll use that first piece if the x value in the parentheses is less than negative 6. We'll use the piece y equals 1 if the x value is between negative 6 and positive 1, including negative 6 but not including 1. And the last piece, the blue piece, x plus 5 if x is greater than or equal to 1. Let me make sure I don't miscopy this thing. Okay, negative 5x minus 10, x less than negative 6, 1, okay, and it's okay. They're going to give us some numbers for x that they want us to plug in to find the y value. Realize there are 3 pieces, but you only use 1 piece for each x value. If the x value, if the number inside the parentheses is less than negative 6, you'll use the red piece. Look at this compound inequality here, the one in the middle. That's saying that x is bounded between negative 6 and positive 1. Notice the little horizontal bar. That's saying x can equal negative 6, but it can't equal positive 1. Now, if x is 1 or bigger than 1, that's when you're going to use the blue piece. And they give us 3. I think it's 3. 1, 2, 3. Let's look back at the problem. They want us to find h of negative 7. Oh, there's 4 of them. So we want h of negative 7, negative 3, 1, and 3. The way we're using function notation, that tells you that if there's 1x, well, any given x, there can only be one y. It's impossible that I plug in 1 and get something like 6, and you plug in 1 and get 15. For each x, there's one and only one y. The x value is the value that's in parentheses. So to decide which piece you're going to plug into, the x value is -7. Which inequality is satisfied? Is -7 less than -6? Or is -7 between -6 and +1? Or is -7 bigger than 1? It can only be one of those three pieces. Red, green, or blue. Which inequality is satisfied by -7? Which one? No, -7 isn't bigger than 1. -7 is smaller than 1.
Wait, sorry. I mixed it up. My brain took out that 7.
Oh, okay. Well, the -7, do you all agree? -7 is smaller than -6. That means we're using the red piece. Plug in the x value, that's -5 times -7 minus 10. We call the order of operations. You multiply, so that's 35 minus 10, which gives me a y value of 25. Any questions there? Now we ask ourselves the same question, -3. Which inequality is satisfied by -3? Is -3 smaller than -6? Or is -3 between -6 and +1? Or is -3 bigger than 1? The green one, I agree. -3 is between -6 and 1. So we're going to plug -3 into the green piece. Wait a minute. There's no x here. This is a constant function. For any number between -6 and +1, the y value is just a 1. Any questions on my logic there?
So it'll just be 1?
And there's no x to plug into. It's just that number 1. What about h of 1? Let's see. Well, 1 isn't less than -6. It's going to be one of these two conditions right here, or one of these two pieces. Which one allows x to equal 1? Okay, I agree with the blue. Notice there's no horizontal bar there for equality, so you can't plug it. You can't use the green piece. The piece that allows x to equal 1 is the blue piece, so you plug the 1 into the blue piece, and there's an x to plug into there. 1 plus 5 gives me a 6. So when x is 1, the y value is 6. What about h of 3? Which inequality is satisfied? Is 3 less than -6? Is 3 between -6 and +1? Or is 3 bigger than 1? 3 is bigger than 1, so you're using the blue piece again. 3 plus 5 gives me a y value of 8. I'm forgetting to box in my answers, aren't I? So we have to go and type in these answers of -7 was 25. -3 was 1. H of 1 was 6. And H of 3 was 8. Okay. I still seem a little hazy there, fuzzy. So how about this one? I'm going to make up one. H of 0. Which piece will we use to evaluate H of 0? Is 0 smaller than -6? Is 0 between -6 and +1? Or is 0 bigger than 1? It's between -6 and +1, which means the y value is, we're using this green piece.
Get set up.
one.
Just that one. There's no variable to plug into. It's just a 1. Oh my goodness, thank you. That's going to be, okay. 0 is between -6 and +1, so the y value is a +1. What about this one?
Oh, these are just examples.
These are just examples.
Oh, okay.
These are the problems. Y'all seem so reluctant here that I thought I better maybe do a few more. What about h of 10? Which piece are we going to use? Piece 1, 2, or 3? 3, because 10 is bigger than 1. There's an x there, so you plug in the x value. That's a 10 plus 5, which is 15. Any questions there? I'll do one more. How about h of, well, we just did h of 10. What about h of -10? Which inequality is satisfied? Is -10 smaller than -6?
Yes.
Is -6 between is -10 between -6 and +1? Or is -10 bigger than 1? Y'all said -10 is less than -6. That means you use the red piece. There's an x to plug into. -5 times -10 minus 10. That would be 50 minus 10. Which gives a y value of 40. To evaluate a piecewise function, you decide which inequality is satisfied by the x value, and that's what you plug into. Any questions there? Okay, the thing that's going to take a little bit longer is graphing piecewise functions. There's not a piecewise function graphing tool in this course, so we'll graph it on paper, and then we'll choose the graph that looks the most like the picture we drew. So for graphing piecewise functions, to graph piecewise functions, we're just going to plot points. Just going to plot points until we see the path that the function is taking. But we're not just going to start randomly choosing x values and plugging them in. We're going to intelligently plot points. We're going to choose the numbers, the x values we're using intelligently. You'll see what I mean. Number 5. I think that's the messiest graph there is. No, it isn't. Number 6. We'll do number 6 first. We'll go back to number 5 in a moment. This is a 3-piece piecewise function. I'm going to graph each piece in a separate color to try to distinguish them. Hopefully you'll be able to tell those colors. Maybe if I turn on the light it'll help. We'll see. But first of all, we have, this is number 6. F of x is equal to we'll use the piece 4 plus 2x if x is less than -4. We'll use the piece just -2x if, how do we say this? -4 is less than or equal to x is less than or equal to 5. And we'll use the red piece, just a +2 times x, if x is greater than 5. I need to make sure I didn't miscopy this, so give me a moment. 4 plus 2x, if that's less than -4, okay. Let me switch to my paper. We've already graphed some expressions. The first, some functions. The first ones we graphed were linear functions, and we said that the equation of a line can be written in the form y equals mx plus b. You can't have an x squared. If it's a line, you can't have an exponent on the x unless it's just the assumed power of 1. You can't have a x under a square root. You can't have an x under a denominator. And when I look at this, y equals 4 plus 2x, that's a line. Y equals negative 2x, a line. Y equals positive 2 times x. These are all three lines. What's the minimum number of points you need in order to draw a line? You need 2 points. So here's what I'm going to do. I imagine y'all aren't doing this stuff in colors. So my advice to you, number the pieces. Piece 1, piece 2, and piece 3. The first thing we're going to do is generate ordered pairs for piece 1. This will be table 1. I said that we would be plotting points intelligently. The first point that you have to come up with is the one that's created by the number appearing within the inequality. Realize -4, that's where the blue graph changes to the green graph. And +5, that's where the green graph changes to the red graph. For a lack of any better word, I'm going to call these numbers here in the inequality cut points. You must always start off plugging in whatever cut points appear within that inequality. I see the number 4, I'm going to have to plug in 4 for x. However, think about solution cut points. There's no equality here. So this point that I'm going to generate is going to be labeled with an open circle. We'll discuss why we're doing that once we're through drawing the graph. Why are we plugging in a -4? X can't equal -4. Do y'all see the problem there? There's no horizontal bar. You still have to use -4 as your cut point, as your starting point. Next, you need to choose a number that actually satisfies the inequality. That's the point that you choose yourself. -4 doesn't satisfy the inequality. That's why we're going to label it open. Now choose an x value that's actually less than -4. Something easy to plug in. I could use -20, but -5, yeah, that's probably the easiest thing. Choose something immediate to the immediate left of -4. We'll use -5. But -5 is less than -4. You chose that number because it satisfied the inequality. So the secondary point, the one that you're choosing on your own, will automatically be a closed dot. When you're choosing the x values yourself, you can't choose an x value that doesn't satisfy this. You couldn't decide, oh, I'm going to plug in 3 here for the blue. 3 isn't less than -4. The number you choose has to satisfy the inequality, so it will be a regular closed dot. Let's plug in -4 into the blue piece. We have, let's see, what's that going to be? We're plugging in -4. That's going to be a 4 plus 2 times -4. That's a 4 minus 8. 4 minus 8 gives me a y value of -4. That's just a complete coincidence that the y value is also -4. We plugged -4 into the blue piece. Now let's plug -5 into the blue piece. 4 plus 2 times -5, that's a 4 minus 10, which gives me a y value of -6. You may not see why we're doing this yet, but any questions on what we've done? You always, when graphing a piecewise function, you always start off with whatever number appears within the inequality. If there's no equal to, then you adjust that with solution cut points. You have to label it with an open circle. Then you choose another x value that satisfies the inequality. The numbers you choose yourself are regular closed dots. So let me draw my XY grid. I'm gonna do a physical zoom there. I'm going to draw myself. Oh, I shouldn't have drawn it up so high. Well, shoot. Because we have to make 3 more tables. When you're drawing your XY grid, you need to make sure that you clearly label your cut points. 5 appeared within the inequality. Label it on the x-axis. What number was the other cut point?
-6.
I think it was -4, wasn't it? -4. Pardon me? Oh, it was cut off. -4 and +5. Make sure they're labeled clearly on the x-axis. We're going to plot the point. This is the blue piece. -4, -4. 1, 2, 3. This is no good, because in a moment I'm going to be plugging in 5 and I'm going to wind up what? Going up 10 and going down 10. Will this go down 10 units? 1, 2, 3. I guess I can start squeezing it in. What do you think? Nah, I don't want to do that. I'm going to draw a real big grid here. I'm sorry about that. I'm going to make a real big grid. So we label 5. We clearly label -4. So we have the order pair -4, -4, left 4, down 4, open circle. And what was that other point we had? Where is it? Right here. -5, -6. Remember I said any point that you choose the x value yourself has to be a regular closed dot. So -5, -6. We go right 5 and down 6 right there. There. Your graph starts at the cut point. It goes towards the secondary point and the interval x less than -4. X is less than -4. So you're looking at this portion of the x-axis. Does that portion of the x-axis ever stop? No. So the left side of the interval never stops. That means the left side of the graph never stops. And once again, we'll discuss why did I even plug in that -4 to start off when there was no equality for -4. We'll discuss that once we've drawn the picture. Any questions on what we've done so far? Now the second piece. That's the green piece. I'll make a table of values. We need 2 ordered pairs. Remember I said any number that appears within the inequality, any cut point must be plugged in. So look at this one. We have 2 cut points. We're going to have to plug in -4 for x. We're also going to have to plug in +5. So we have to plug in -4 and +5. So there's no, you're not going to be choosing an x value yourself. They've given you the 2 numbers you have to plug in. Let's look at this. Remember the rules for solution cut points. Equality is allowed for -4, so that's going to be a plain closed dot. What about for +5 on the green piece? Is equality allowed? Right here, the green piece that I'm pointing at. Can x equal 5? Yes, that horizontal bar. So this is actually very nice. It's going to start and end with a closed dot. Let's plug in -4. -2 times -4, I better write that out. We have a -2 times -4. What is that giving me for my y value? We plug -4 into the green piece. 8, okay. There's my first y value. Plug in 5 into the green piece. I bet you can do that without me showing it written out. What are we going to get for y when we plug 5 in to the green piece? -10. -2 times 5 gives me a y value of -10. Does this interval keep going and going in any direction? The blue interval kept going forever to the left. The red interval is going to keep going forever to the right. But I claim this middle interval, it starts at -4, it stops at 5, so you're not going to have any arrowheads on this middle piece. You start at -4, 8. You put a green dot. 1, 2, 3, 4, 5, 6, 7, 8. Okay, -4, 8, a green dot. You plug in 5. What did we get? -10, was it? 5 gave us a y value of -10. Oh, goodness. Am I going to be able to get down? Is it going to... Am I have to move the paper? Let's see. -5. That's -4. -5, 6, 7, 8, 9, 10. So write 5 down 10. Is that fitting onto the screen? Yes. We labeled -4 +8. We labeled 5 -10. They were closed dots. The interval doesn't keep going forever. This portion of the graph is just a line segment. Starts there. Oops, sort of missed it. You know what to do if you miss the point? I remember that from middle school. You make the point bigger. If you miss it, just make it bigger. There. We plugged in -4, we generated the y value 8. We plugged in 5, we generated the y value -10, and we connect the dots. There's one more piece, the red piece. Let's make our table here. This will be the third table. Look at the inequality. Are we going to have to make up an x value? Well, first of all, what's the first x value I have to write here on the table? 5. I have to use 5. Now, am I going to have to choose one on my own like I did in the first table? Or is this third piece like the second piece where both numbers are given?
Like the first.
Is that the first? You're going to have to choose a number that's bigger than 5. What do you want to plug in? Something bigger than 5.
6.
I'd use 6. Oh, I forgot to ask y'all. When we're plugging in 5, 5 is a cut point. There's no equality. So am I going to label this point that I generate with an open circle or a closed circle? Which one? Open, because there's no equality. But for the secondary number, the number you chose yourself, how do you label it? Is it going to be an open circle also?
Yeah.
You're choosing a number that, do you understand why we're putting an open circle? We're putting an open circle for 5 because 5 isn't bigger than 5. 5 is equal to 5. 5 doesn't satisfy the red inequality. What about 6? Does 6 satisfy it? Yes, so that's a regular closed dot. The numbers you choose on your own have to be regular closed dots. The only time when I plug -4 into the blue piece, I can have an open circle on the graph. When I plug 5 into the red piece, there's no equality, so I'll have an open circle. What are these y values here? When you plug in 5 into the red piece, what am I going to get? 10. 2 times 5 is 10. When I plug in 6, what am I going to get? 12. So, we come over here, we're plotting the point, 5, 10, right 5 up 10, there. So right 5 up 10, we have an open circle. Uh-oh, we need a 6. Here's 6. And we're going to have to go up to, what is it, a 12? So 6, if that's 10, there's 12. Right 6 up 12 right out there. You start at the cut point and you go towards the other point. Does this interval stop? X bigger than 5, it starts there and it keeps on going, so the right hand side of your graph keeps going. You can have at most 2 arrowheads on your graph. On the rightmost portion, you can have an arrowhead, and on the leftmost portion, you can have an arrowhead. Any middle piece, no arrowhead. Those middle intervals, they start and stop. If you have 2 cut points on the intervals, then you're looking at a line segment. Otherwise, only 1 cut point, you're looking at a ray, which is half a line. Any questions there? Let's choose the correct answer before we get timed out. Then I want to discuss, why did I plug 5 into this thing here? Let's see, can y'all? Oh, I think we're going to have to blow these graphs up. Oh, that might be it. Oh, what are they doing? Incrementing in units of 2? Let's see, 2, 4, so that's -4, -4. I think this is it. But let's look, let's discard the others. B, clearly not B. C. Does C look like our picture? No. D? No. So A would be the correct graph. Any questions there? I need to discuss something. Why did we plug in -4 into the blue piece to get that starting point when there's no equality? Why did we plug in +5 into the red piece? There's no equality. I think the easiest way to understand this is to look at the red piece. I claim that the real number system is that between any 2 real numbers, there are infinitely many other real numbers. I claim that there are infinitely many numbers sitting right beside 5 on the x-axis. Here's the x-axis. I knew this grid would come in useful for some reason. I claim right here to the immediate right of 5, there are infinitely many numbers that look like 5 to the naked eye, that are bigger than 5, so they satisfy the inequality. For example, 5.000001. If I told you to show this number to me on the x-axis, what would it look like I was pointing at? What number on the x-axis would it look like I was pointing at if I wanted you to label 5.000001? It looked like I was pointing at 5, wouldn't it? But this number is bigger than 5. So you use the red piece. 2 times that gives you a 10.1, 2, 3, 4, 5. This ordered pair, 5.000001, 10.000002. That ordered pair is on the graph. It is on the graph. So we have to label this point. To the naked eye, what does it look like I'm labeling? When I'm trying to label this 5.000 stuff and 10.00, what does that ordered pair look like? 510. It looks like 510. So this open circle is saying 510 is not on the graph, but there are plenty of points that look like 510 that are on the graph. That's why you have to start off plugging in that 5 on the red piece, even though 5 is not bigger than 5. Likewise, there are -4 is not on this graph. But there are points right there that look like -4 that are on the graph. That's why you must start off by plugging in any cut point that appears within the inequality, even if there's no equality. Any questions there? Now we'll back up to a simpler one. Oh, what did I do? There it is. Let's go back. We're going to go back to number 5. This is nice. It's just a 2-piece function. Okay. So this is number 5. Let me write the problem down. F of x equals, there are 2 pieces here. We'll use the piece a y value of -3 if x is that less than or equal to 0? Yes. We'll use the red piece -2 if x is greater than 0. What's my cut point? On the x-axis, at what number will the green piece change to the red piece? There's only one number appearing within those inequalities. What is it? 0. You see a 0. 0 is the cut point. So there are 2 tables. We're going to make 2 tables, table 1 and table 2. Starting with table 1. I don't have a choice. What's the first number I must plug in for x in the green piece? What's the first number what number am I going to write here?
0.
0, the cut point, the number that's on the inequality. Now, can x equal 0 in this green piece? Yes, so it's going to be a regular closed dot. But we need another x value. Now choose a number that's smaller than 0. Could I use 5? No, I have to use a number that's smaller than 0. What do you want to use? -1. Now, the numbers you choose on your own, they must satisfy the inequality, so there's no question open or closed. It's automatically closed. Oh, this is nice. For the green piece, what will the y values be? There's no x to plug into them. The y values will be
-3.
-3, okay. Why don't we make our second table also, and then I'll draw the xy grid. What's the first number I have to use for x? I couldn't hear you. 0. I have to use 0. You say, well, there's no equality. That means this cut point is going to be labeled how? We're plugging in a number that doesn't satisfy the inequality, so this cut point will be labeled open. We need an x value that does satisfy it. Give me a number that's bigger than 0. 1. What did I say? How do you label the secondary points that you choose yourself? Always closed. What will the y values be in this case? -2. So we draw our xy grid. and clearly label 0 on the x-axis. Well, 0 is there at the point of intersection. There's 0. To the left of 0, we have, well, 0, negative 3. So we're at 0, go down 3, it's a closed dot. Then negative 1, negative 3, go left 1, down negative 3. We start at the cut point. We start at the cut point, and we go, is this thing going to stop? We started at the cut point, we went to the secondary point. Is this going to stop?
No.
Did the inequality have 2 cut points in it? No, that means it keeps going forever in that direction. If you're not going to have a cut point, the only way you don't have an arrowhead is if your inequality is like this middle one here, where it starts and stops. That piece won't have an arrow, or didn't have an arrow, but the piece on the left will continue going forever to the left. The piece on the right will continue going forever to the right. So there's half the graph. Now this one, 0, negative 2. That means you go left, right, 0, down 2. You have an open circle. What's the other point we have to label?
1 and negative 2.
Right 1, down 2. Is that going to be an open circle?
Yes.
No, remember, it's the number you choose yourself. That's automatically a regular closed dot. You always start at the cut point. You go to the secondary point. Does it stop?
No.
No. Any questions there? A graph like this is frequently called a step graph, because you're literally going one step, then you step up to the next piece. Let's look at the possibilities. A. Oh, I thought that was it, but what's wrong?
The open circle.
They've reversed the open and close, so you got to be careful. Is it B? No, clearly not. C? I think that's it. It's open on the top piece, closed on the bottom piece. D, clearly not. So I agree with response C. Any questions there? Realize these are functions and they're passing the vertical line test. If it's a function that has to pass the vertical line test, look at this picture here. Right here, the x-axis is acting like a vertical line. I claim it only intersects the graph in one point. It intersects down here at this solid green dot. This thing here, that point isn't on the graph. And so yes, these tests, these piecewise functions have to pass the vertical line test. That red open circle is not on the graph. The green solid dot, that's the point that's on that graph, the y-axis. Any questions there?
On the answers, like on the multiple choice, what was the difference between C and D?
Let's look back. Let's see. Okay, we're looking. C. Oh, well, no, this is B. Did you want B? Which one did you?
C and D.
C and D. Okay, C and D. C is the correct one. Okay, right here. Open circle, going to the right on the top. Solid circle, going to the left on the lower one.
C.
And
Okay.
D has the pieces reversed. The open and closed are correct, but this one has the upper one on the left-hand side. So they reversed the less thans and greater thans.
Okay.
Any other questions there? Number 3. Same instructions. We're drawing the graph. f of x is equal to, there are two pieces here. We'll use the piece x minus 4 if x is less than or equal to 1. And then we'll use the piece negative 3 if x is greater than 1. X minus 4, x less than 1. What's my cut point? What number must I start off plugging in each piece? I have to use the number 1. There's only one cut point. I'm going to have to use the number 1. Let's see. This is table 1. I must plug in 1 for x because that's my cut point. It appears in the inequality. Now when you're labeling cut points, it's either open or closed. What will it be in this case? Closed because there's equality. Now we need another x value, a number that's actually smaller than 1. Could I use 0? Yeah, I could use 0. And any number you choose on your own is automatically a closed dot because you can't decide. I'm going to use 2 in the green piece. 2 isn't less than 1. So plugging in 1 into the green piece, we get a 1 minus 4, which gives me a y value of negative 3. Plugging in 0 into the green piece, what am I going to get? Negative 4. Let's make the second table while we're at it. And then I'll draw the XY grid. This is piece 2. What's the first number I must use for x? 1, but there's no equality, so how will I label this point? Open circle. I need another point. I need a number greater than 1. 2, okay. The secondary points you choose are labeled how? Closed. Always closed. Oh, this is nice. There's no x to plug into, so what will the y values be? Negative 3. Oh, we don't need too big a graph here. Got to clearly label that cut point on the x-axis because that's where the pieces are going to change. And so that would be at 1. Our cut point is 1, negative 3. Write 1 down 3, and it's a regular closed dot because x can equal 1. Then 0, negative 4, right there on the y-axis. It starts at the cut point and it goes towards the secondary point. Does it stop? No. X less than negative 1, that interval keeps going forever, so we have an arrow on the left side. Now the right side, the red part. We go to 1, negative 3, expecting to put an open circle. You go right 1, down 3, and what do you discover you have? A closed circle. If you have both an open and a closed circle taking place at the same point, your graph will have a closed dot. Closed dots take precedence over open dots. Why? Well, this open dot is saying 1, negative 3 isn't on the graph. But yes, it is. It's on the graph for the other piece. That's why if you have an open and a closed dot occurring at the same spot, your graph will have a closed dot. So there's my starting point. And then 2, -3. Write 2 down 3. It starts at the cut point. It goes to the right. Does it stop? No, it doesn't. Once again, the only way the pieces are going to stop, the only way you won't have arrows on the left or on the right, is if the inequality, where is it? The inequality has a lower bound and an upper bound. Any questions? The reason I wanted to do this problem is what happens if you have an open and a closed dot at the same spot? Your graph has a closed dot. That open dot there said that 1, -3 isn't on the graph, but yes it is. It's on the graph for the other piece. Any questions on our logic there? A, no, clearly not. B,
No.
am I looking at the right problem? They're not even close, are they? C, it better be D. D, yeah, it looks like they're incrementing in units of 2, 2, 4, 6, 8, 10, so yeah, looks like response D.
I don't like that.
You don't like it when they start incrementing in units of 2? I don't either. And so that's why I go through this. I guess like on that first problem that we graphed, I could have just said, oh, I'm going to only increment in units of 2, and it would have fit here. Oh, wait, y'all can't see what I'm pointing at. I like it better when it's all units of 1. Once I stage the coup and take over the world, along with the other restrictions that I've said I would impose regarding variable selection, things like no B variables because it looks like a 6. Another thing I'm going to impose, as I'm a ruler of the world, I'm going to say XY grids must be in units of 1. Y'all think y'all would support that idea? Until you have to plot something like -127, -53. Then you'll be opposed to that idea. Any questions there?
About your political system or the actual?
No, about the problem itself. I'm almost 61 and I'm beginning to think there'll never be a time when I get to take over I'd be a very benevolent dictator. I'd love everyone, except I have some problems with some variables and some incrementing on x's and y axes. Most of my rules and laws would involve mathematics, I will be honest. You want to do something else? I don't care about that. I want to make math easier. Okay, any questions? Oh goodness. And I need to do some writing first. Quite a bit of writing. The second topic in this assignment, quadratic functions. We've already graphed quadratic functions. When we were graphing that first assignment that had all those different graphing tools, we graphed quadratic functions using a 3-point quadratic formula tool. And I said this isn't a very good graphing tool. We'll get a much better graphing tool later on. Well, we're up to that point. Quadratic functions. A quadratic function will be in the form y equals or f of x equals a quadratic expression. Remember we said quadratic had to have an x squared term. You couldn't have an x cubed, you can't have a square root of x. It's just ax squared plus bx plus c. Just like a quadratic equation was ax squared plus bx plus c equals 0. We said the graph would be a smooth U shape called a parabola. We're only going to graph parabolas that are functions. That means they'll either open, upward, or downward. And it's a U shape. Notice it's smooth. It's not a V shape like that absolute value function expressions that we graphed several weeks ago when we were looking at graphing. Well, I guess you could have a U. We have U's that could open left and right. But hopefully you agree, if you had a parabola laying on its side, it wouldn't pass the vertical line test. That's not a function. So we don't have to graph those things. We only graph the ones that open up or down. When you look at the equation itself, you can draw some conclusions. Based on the number in front of x squared, if a is positive, you expect the parabola to open up. If that number in front of x squared is negative, you expect it to open downward. Either way, there's a point at which the graph changes directions. When a parabola is opening upward, that point where it changes directions is the low point on the graph. That point, when it's opening downward, the point where it changes directions is the high point on the graph. And that thing is called the vertex. This point and that point, that's the vertex. There or there. There are two generally accepted methods of finding the vertex of a parabola in an algebra course. One of them involves completing the square. The other one is something called the vertex or axis formula. We're going to take the vertex or axis formula approach. You use the same formula to find the vertex and the axis. And they're going to ask you to find the axis anyway, so we may as well just use this formula here. It's an easy formula to remember if you know the quadratic formula. Okay? The vertex formula is the vertex will occur when x is equal to, it's a fraction. Think about the quadratic formula. It's negative b, and then it's that plus minus the square root of b squared minus 4ac all over 2a. It's the quadratic formula without that messy stuff, the plus minus square root stuff. It's just negative b on top, 2a on the bottom. If your parabola is opening upward, you'll find where even if it's opening downward, you'll first of all determine where the vertex occurs. You'll plug that number in to get the y value of the vertex. Realize when a parabola is opening upward, that y value will be the lowest y value on the graph. That's the smallest y value on the graph like that. So that vertex corresponds to a minimum y value. That means it's the smallest y value on the graph. When a parabola is opening downward, the vertex is the highest point on the graph. That means this point here is bigger or is taller than any of the other points. So when a parabola is opening downward, that y value corresponds to the maximum y value on the graph. Now, what do I mean by the axis? The axis is an imaginary vertical line that passes through the vertex. So these things are mirror images. Draw a vertical line through the vertex. If I tore this paper out and folded it down that vertical line, the right-hand portion should lie directly on top of the left-hand portion. They're mirror images. Same thing's true here. You say, well, they don't look like mirror images. It's human error, okay? But they should. If I folded this paper down this imaginary axis here, the right-hand portion should lie directly on top of the left-hand portion. Any questions there? And we're going to take advantage of this when we're graphing the parabola. What we'll do is we'll determine the vertex and plot that point. Then, with that graphing tool, it's like that absolute value graphing tool. You found the vertex, you found one other point, and then the graphing tool takes advantage, draws the second half of the graph for you. That's what we'll do here. To graph a parabola, you'll use negative b over 2a to find the vertex. Then you have to find one other point. You'll have to choose the x value yourself that you want to plug in. Then find one other point. That's all you need to use the quadratic graphing tool that's built into this homework assignment. They're going to ask you for some other information. They're going to ask you for the domain. All quadratic functions have the same domain. For the domain, let's look back. I seem to recall my brother saying something in the last homework assignment. With the quadratic function, look at number 9, okay? Just to see an example. Here's a quadratic function. F of x equals negative 4x squared minus 40x minus 96. If it's quadratic, you can't have variables under square roots. You can't have variables in denominators. What did we say on that Wednesday before spring break about the domain of functions with no square roots and no denominators? Let's see. Here it is. Let's look at these. Here are our notes from that last class meeting. What did he say? Let's see. It's down here. Look at this part right here. If your equation has no fractions and no square roots, the domain is all real numbers, negative infinity to positive infinity. You can plug any number you want to in for x. If it's quadratic, you're not going to get an imaginary number. You're not going to get a denominator of 0. So the domain, all real numbers. The range is going to require a little more thought. They'll ask for the range. When you look at these problems, don't you love the problems that have all these different parts to it? Well, the vertex and the axis, that's where you use the minus b over 2a. That's not bad. The domain. Part C, we know that's all real numbers. Even if you went back to something like number 8, it's a different quadratic function. The domain is still all real numbers. The range is where we have to do a little thinking. Let's suppose we have a parabola. Let's have it opening upward first. Suppose a parabola is opening upward.
We need to see it.
Oh, well, let me switch over. Thank you. And for this example, let's say that the vertex is at the ordered pair. I'm just going to choose two numbers. That's the ordered pair 3, 4. If a parabola is opening upward, that y value on the vertex is the minimum y value. That means the range, it starts at 4. And what about the y? Does it keep going up and up forever? Those arrows there, if it's a parabola and it's opening upward, the smallest y value would be 4. But there isn't a biggest y value. It just keeps going up forever. If the parabola is opening upward, the y-coordinate of the vertex is the minimum y value. So your range, it starts at 4 and it goes forever. Let's generalize that. It doesn't matter what that y-coordinate of the vertex is. If you're trying to determine the range of a parabola that's opening upward, the first number will be the y-coordinate of the vertex. Y-coordinate of vertex, comma, then it keeps going and going forever, positive infinity. It starts at the y-coordinate of the vertex and it goes up forever. To determine the domain of a quadratic function, you don't need to look at the graph. You know it's going to be negative infinity to positive infinity. But for the range, you have to look at the graph, analyze it to figure out what the range is. If it's opening upward, the vertex corresponds to the minimum y value, the lowest point on the graph, so it's the y-coordinate of the vertex up to positive infinity. Let's apply that same logic. Suppose the parabola is opening downward. And let's suppose the vertex is still at 3, positive 4. Let's state the range in this specific case. If the parabola is opening downward, we said that y value at the vertex was the maximum y value. That's the highest point on the graph. So, remember, interval notation has to go small to big. So, well, does this thing keep going and going forever? Yes. So, negative infinity, comma, the maximum y value of 4. Remember, interval notation goes small to big. The smallest y value is 4 when it's opening upward, going to positive infinity. When it's opening downward, the biggest y value would be 4, and every number less than 4 can be used. Any questions on my logic there? I think I'll draw a little squiggly there to separate opening up and opening down. Let's generalize. In general, if a parabola is opening downward, the range will start parentheses, negative infinity, comma. How do we determine what number goes here? It's the y-coordinate of the vertex. Y-coordinate of vertex. And we put a bracket because that number is being used. There's a point that has 4 as the y-coordinate. You'll be asked to find the vertex and axis, domain, and the range. I think that's everything you need to know about a quadratic function in order to be able to graph these things. Any questions? Oh, goodness. It's not as bad as it sounds. Number 9. Okay. When I look at this graph, f of x equals negative 40x negative 4x squared minus 40x minus 96. Okay, this is number 9. F of x equals negative 4x squared minus 40x minus 96. Oh. And I'll need us to find the vertex, axis, domain, and range. When I look at this function, I know the general shape. Look at the number in front of x squared. Is that positive or negative? Negative. If that a value, the number in front of x squared, is negative, you expect the graph to be opening downward. So even before I start drawing the graph, I have a good idea. I know the graph is supposed to look like that when I'm finished. Let's determine the location of the vertex. Using our little vertex formula, x equals negative b over 2a. Remember, a is the number in front of x squared, b is the number in front of x, and c is that constant. What's b? So it's a negative 40, and once you apply the double negatives, the opposite of negative, that's going to become a positive 40, which is what you said. What are we going to have down here? A negative 4, I agree. What's 2 times negative 4? Negative 8. Negative 40 40 divided by negative 8 says that the vertex is going to occur at negative 5. That's just the x-coordinate of the vertex. Any questions? The negative there, the opposite of negative 40, became a positive 40. A was a negative 4. 2 times negative 4 gave me a negative 8. 40 divided by negative 8 gives me a negative 5. So that tells me where the vertex is going to occur. Let's make a table of values. You're going to have to plug in negative 5 and make a little note. That's where the vertex is going to occur. And you might want to have your calculator handy. Oh, is it going to open? Yes, there it is. Let's plug negative 5 into the function. We have a negative 4 times negative 5 squared minus 40 times negative 5 minus 96. We're plugging in the negative 5. This y-coordinate is what we're going to have to use when we're finding the range in a moment. Let's see, that would be 25, a negative 100 plus 200. That's a 100 minus 96. I'm getting a positive 4, but I know y'all want to see it on a calculator. Trusting me is overwhelming. Negative 4, parentheses, negative 5 squared minus 40 times negative 5 minus 96. Oh, look at that. It agreed with what I got. We need another point. To graph a quadratic function using this new advanced tool, you need the vertex. You need one other number. Now, what's my favorite number to plug in because it's so easy? 0. You're not going to be able to use 0. If you use 0, what are you going to get for y? That's going to become 0 minus 0 minus 96. So what would you have? If you plugged in a 0, you get a y value. I can assure you the grid they're going to give you to draw this graph will not go down 96 units. You're going to have to be careful. That's one of the disadvantages. You're going to have to make sure that the point you choose, we may as well go ahead and type in the vertex. They want it typed as an ordered pair. It's not just that negative 5. What was that ordered pair we found? Negative 5, 4. Let's go ahead and type that in. Parentheses, negative 5, comma 4. Look at this grid. It only goes up, down, left, and right 20 units. You're not going to be able to go down 96 units. So, here, I said that you'd find the vertex, and then you have to find one other point. My advice to you, only move 2 units away from that x value of the vertex. We could use like a negative 3 or a negative 7. We could use a negative 4 or a negative 6, but that would jam the stuff in so tightly. Don't move more than 2 units away. If you do, you're going to get a number that won't fit on the grid. Is that clear? So over here I said we would, to graph a parabola, use negative b over 2a to find the vertex, then find one other point. That one other point, you don't want to move far off from negative 5. We could use negative 3 or negative 4. We could use 6 or negative 7. I bet you if you use, say something like negative 1, you'd get something way too far off the grid. So for our purposes, you're choosing, what do you want? I'll use either a negative 3 or a negative 7. It doesn't matter to me. We'll still get the same graph at the end. What number do you want to plug in for x? Negative 3. So we have negative 4 times negative 3 squared minus 40 times negative 3 minus 96. Let's see, that's what, a negative 36 plus 120 minus a 96. Let's see, 120 minus 96, is that a 24? And what did I say here? I'm getting a negative 12. We better check that. Let's check it. Where's my calculator? Negative 4. We're plugging in a negative 3 squared minus 40 times negative 3 minus 96. Okay, negative 12. It's still a good idea to check. My brain is still sort of on spring break. So we come over here. I'm going to pop out the grid. Whether the parabola, we've already said our parabola is going to open downward, okay? We said it's going to open downward. How did I know that? Something in the original problem told me. What was that? That negative, that number, if that starting number, the number in front of x squared, if it's negative, it's going to open downward. So it's going to open downward, but there's only one quadratic graphing tool here. It looks like a parabola. It's opening upward. The vertical parabola tool. We're only graphing parabolas that are vertical. They open up or down. Click that. You need to plot the vertex. And what was our vertex? Negative 5, 4. Is that it? Y'all see in the yellow box where it says negative 5, 4? I click it. And now notice as I move my mouse around, it's drawing every possible parabola that has a vertex in negative 5, 4. We only need one other point. Well, what was the other point that we found? Negative 3, negative 12. Negative 3. Let me see. Oh, I skipped it. Is that it? Negative 3, negative 12. Look at that. It's underneath that X up there. Do y'all see where it says negative 3? No, I moved it again. Try it. There it is. Click it. Okay. Save it. There used to be things called mouse pads. Do they still exist?
Yes.
Yes? I wonder why we don't have any mouse pads in this class. So we don't have them over there. I think that'd make it easier me using this mouse. Okay. Now we still need, don't you just love these problems with all these different parts? We need the axis, the domain, and the range. The axis is a vertical line, and when we were graphing vertical lines, we said vertical lines are always in the form x equals a number. So it's not just negative 5, it's x equals negative 5 that you're going to have to type in. The domain, no fractions, no square roots. What did I say the domain of any quadratic function will always be? No fractions, no square roots. The domain is all real numbers, negative infinity to positive infinity. Now the range. Look back at the graph. Well, first of all, remember the parabola is opening downward. So it's going to start off with a parenthesis, negative infinity. And it's going to have a bracket. What is that right-hand endpoint on the interval notation? How do you determine that? It's the y-coordinate of the vertex. This parabola, the biggest y-coordinate on that graph is a 4. Look at the picture we drew. There's that top point. The y-coordinate is a 4. Are there any other points up here that have y-coordinates? These are bigger than 4. Or is any of the graph up here where I'm moving the mouse?
No.
No. The biggest y-coordinate on the graph is 4. So when we're writing our interval notation for the range, it has to be small to big. Negative infinity, comma, 4. Any questions there? Okay, so we come over here. Type an equation. You can't just type negative 5. You have to type x equals negative 5. And the domain, wait a minute. The domain, negative infinity, comma, infinity. Always put negative infinity to infinity in parentheses. And the range, parentheses, negative infinity, comma, what was that y value? 4, bracket. Any questions there? I know it's getting late and y'all are getting tired, but I think we need to do another one with these different parts. So we'll go back to number 8. Now, here's something, I know some of y'all are going to be leaving before I'm through, but I want to mention something. The word problems at the end, before I even do number 8, I want to mention there are some word problems at the end of this assignment, but they're easy word problems because they're always going to be asking you either for a maximum or a minimum. If it's a quadratic function, whether it's a maximum or a minimum, where is it going to occur? At the vertex? So if you're one of the people that's going to be leaving in a few minutes and I haven't done any of the word problems, my advice to you, you're going to have to use that vertex formula. Then you have to plug the number in to get the y-coordinate, but for finding maximums and minimums, it always occurs at the vertex for quadratic functions. And I want to go on to back to number 8. Let's see. Let me write the problem down. And while I'm writing it down, I have a question for you. Is this parabola like the previous one? Is it going to be opening downward or will it be opening upward? Upward. What's my A value here? A positive 1. Okay. My A value is a positive 1. That means I expect my graph, once I draw it, I expect it to be opening upward. Let's use our vertex formula. X equals negative b over 2a. And let me put my little 2 there. What's my b value? Looking at the original problem, remember a is a positive 1. What's b? Negative 14, so watch those double negatives. In a moment, the opposite of negative 14, that's giving me a positive 14. What about our A value?
Times 1.
Oh, I'd already asked y'all, and I already said 1, hadn't you? 2 times 1 is 2. That means my vertex is going to occur when x is equal to 7. Okay. And down here towards the bottom, they're gonna ask us for the vertex, axis, domain, and range. Before we draw a graph, before we do anything else, I know what I'm going to write for the domain right here. What is it?
Infinity.
Negative infinity to positive infinity. We know the axis now also. What's the axis going to be?
7.
Not just 7.
X equals 7.
X equals 7. Now the vertex, we know the vertex is going to occur with an x value of 7. We better go ahead and make ourselves a table of values. I didn't need to skip down there that much, did I? Because the graph will be done on the computer. I didn't need to leave all that space there. Well, it's too late. We're going to have to plug in 7 for x. Plugging in 7 for x. We're plugging in 7. We're plugging in 7. That's a 49 minus 98. That's a negative 98. Negative 98 plus 40. No. 49 minus 98 is a negative 49. Negative 49 plus 45. I'm getting a negative 4. Did I say, what did I say? Did I say something wrong? You know, we better, where's my calculator? Y'all are right. Why am I trying to do mental arithmetic the day after spring break? I'll just punch it in. 7 squared minus 14 times 7 plus 45. I got a negative 4. Yeah, okay. So a negative 4. Now we need another number. 0 would be easy to plug in, but if you did, what would you get for y? If you plug in 0 for x, we can make a generalization. If you plug in 0 for x in a quadratic function, that number right there will always be the y value. Do you think they'll let you move up 45 units? No. So move maybe 2 units away from 7. I think I'll use 5. We could use 6. That's sort of jamming it close together on the x-axis, but okay. You could use 8 or 9, but I wouldn't use 10. I think 10 would be too far off. Choose a number that's close to that x value that you found using negative b over 2a. So we're going to plug in 5. Let's see. That's a 25 minus 70 plus a 45. 25 plus 4. Oh, now I better check this because I'm getting 0. Let's see. 5 squared minus 14 times 5 plus 45. Okay, my mental arithmetic wasn't off there. 7 negative 4 is my vertex. All we have left is our range. The parabola is opening upward. The parabola is opening upward. Is that vertex going to correspond to a maximum value or a minimum value? Is it the high point or the low point? The low point, it's a minimum value. So remember I said the range will, the y coordinate of the vertex, that'll be the smallest y value on the graph. The smallest y value on this graph is going to be negative 4. to positive infinity. We better start plugging in, typing in the answers. The vertex we said was 7, negative 4. Oh, we have to draw the graph. You click your vertical parabola tool, and then the first point you plot is the vertex, 7, negative 4. 7. I bet I'm just aggravating some of y'all out there. Y'all want to come up here and grab this mouse and get it to the correct spot yourself. I know if I were a student, I'd be the same way. I'd be like, give me that thing. Okay, 7, negative 4. And then we have to click the one other point we found, that other point we found. Now this is a nice point. What is it? 5, 0? Is that the second point? Am I at 5, 0? Yes. Save it to transfer it. Check answer. The axis, x equals 7. I think there's one problem for the axis. I think it's number 7. They type x equals for you, okay? So you don't have to type it. But for all the others, they're not giving you the x equals. You have to type it. And the domain, all real numbers. And the range, that's a bracket. The smallest y value on the graph is negative 4, and it goes up to infinity. Any questions there? But I think number 7, they're trying to be nice for you, and since it's the first one, and the axis, they type the x equals, but and all the others for the axis, when they ask for it, you have to type that x equals. And if you don't, they'll count it wrong. And in the homework, that's fine. You can correct it. But on the test, you don't get that option to. So be careful. Any questions there? Okay, some applications. Let's see. I better switch over to my paper first. Applications of quadratic functions. That means word problems. In these application problems, they're going to be asking you to find maximums or minimums. You'll have to find maximum or minimum values of a quadratic function. Well, we've already said a maximum or a minimum will occur at the vertex. If the parabola is opening upward, you'll have a minimum y value, but no maximum. If the parabola is opening downward, you'll have a maximum y value, but no minimum. So, to find that, you'll have to use the vertex formula. Use x equals minus b over 2a. And then plug that number into the function. That looks bad. Plug into f of x, or whatever the function is. This is number 11. Let's see. A woman has a taco stand. She found that her daily costs are approximated by C of x equals x squared minus 40x plus 960, where C of x is the cost in dollars to sell X units of tacos. I don't think a unit of taco is a single taco. I think that probably it's like a dozen or something. Find the number of units of tacos she should sell to minimize her costs, and what is the minimum cost? Now, this woman has some mathematical ability. Surely she didn't hire a consulting firm to come up with her cost function there, that's C of x. Maybe she had a little mathematical knowledge and used some correlation or something to come up with that function. But where she came up with it, it doesn't matter. Her cost function, let me write this down. C of x is equal to x squared minus 40x plus 690. And we want to find what are they asking for, a maximum or a minimum? They want us to find the minimum. Let me switch over, let me make sure to miscopy this. X squared minus 40x plus 690. They don't ask us to draw a picture. And we're not going to have to graph this thing, but suppose we were going to graph it. It's quadratic, that means it's a parabola. Do you expect the graph to open up or open down?
Up.
Up. That leading coefficient there is what?
Positive.
A positive 1, so we expect the graph to open upward. If the parabola is opening upward, what does the graph have? A maximum y value or a minimum y value?
Minimum.
A minimum, and where does that minimum y value occur?
Bottom.
Now, down here at the bottom, it's called the vertex. That's why I said you're going to have to use that vertex formula and plug it into the function. So, let's use our vertex formula. What's B?
40. Negative 40.
Negative 40. What's A?
1.
A 1. Oh, so what is that going to be? That's a 40 divided by 2. Watch those double negatives. That becomes 40 divided by 2. So what is X? 20. Is that saying that her cost is $20? Look at how they worded this problem. Is X 20? What is X representing? Oh, okay. The X is the number of units of tacos. That's saying that it looks like if she wants to minimize her costs, she needs to sell 20 units of tacos. Surely that's more, and that's why I'm saying a unit has to be more than just one, okay? I mean, I'd hate the thought of her just selling 20 tacos in a whole day. But, so X is 20 tacos. If she wants to minimize her cost, she needs to sell 20 tacos. But what is the cost? How much is it going to cost her to find that, to run that taco stand if she's selling 20 tacos? Once you know the X value, what do you do to find the Y value? Once you know X, what will you do to find Y? Okay, plug it in. Okay, so the cost of 20 tacos, you're plugging 20 in for X.
You want it?
Oh, wait a minute. Thank you. Thanks. The cost of producing 20 tacos minus 40 times 20 plus 6. Plugging in a 20. That's a 400 minus 800. 400 minus 800, that's a negative 400. Plus 690, I'm getting a 290. It's going to cost her $290 that day if she produces and sells 20 units of tacos. All right. Where's my calculator? I know that's what you want to see, so just to verify. So it's 20 squared minus 40 times 20 plus 690. Sure enough, it's going to cost her $290 that day to operate her taco stand. The number of units of tacos she should sell is 20 tacos. And what is that minimum cost? $290. Any questions there? Realize the way we identified A, B, and C when we defined quadratic functions. Remember we said that A is the number in front of x squared, B is the number in front of x, and then the constant c. So keep in mind, A is the number in front of x squared, B is the number in front of x. So, number 12. The number of mosquitoes M of x in millions in a certain area depends on the June rainfall x in inches. The function that models that phenomenon is M of x equals 16x minus x squared. Oops, I miscopied it. M of x is equal to 16x minus x squared. Find the amount of rain that will maximize the number of mosquitoes, and what is that maximum number? So apparently, according to this problem, I always thought the more it rained, the more mosquitoes there were, but according to this problem, they're saying that after a point, if it keeps on raining, what happens? The mosquitoes drown, I guess? I don't know. They don't ask us to draw a graph. They want us to find the max. We need to make sure that there is one. They don't ask us to draw this graph, but if they did, do we expect it to be opening upward or downward? What is my A value? Be careful. I couldn't hear you? -1. A is not 16. A is the number in front of x squared. A is -1. That means the parabola is going to open downward. If it opens downward, do we expect the function to have a maximum or a minimum? A maximum. You see, they want us to find the max. It better be opening down if they're looking for a max, or else a maximum doesn't exist. Where does that maximum occur?
Vertex.
At the vertex. So we got to use the vertex formula again. Negative b over 2a What's b? Be careful. 16. Remember, b is the number in front of the x term. It doesn't matter which one's written first. By our definition of quadratic, b is the number in front of x, a is the number in front of x squared. So b is 16 and a is -1. -16 divided by -2 is going to give us a +8. Watch those signs. Would it make sense for us to have gotten a negative x value here? Would it have been sensible to say there need to be -8 million mosquitoes? No, negative numbers are not counting numbers, and that's true pretty much for all of these. Look at number 11. Would it have made sense for that woman, for her to have sold -20 units of tacos? For these word problems, you better make sure you're getting a sensible answer, which means a non-negative x value. So X is the number of inches of rain. That is not saying 8 million mosquitoes. X is the number of inches of rain. Oh, X inches of rain. So we know how much rain there needs to be to maximize the number of mosquitoes. There should be 8 inches of rain. How do we find the value of the function? What are we going to have to do? What will we do? Once you know the X value, how do you find the Y value?
Oh, plug it in.
Plug it in. So, the number of million mosquitoes when there are 8 inches of rain, 16, we're going to have an 8 and an 8. That's 128 minus 64. I'm getting 64 million mosquitoes. I don't like that slang reference to mosquitoes as mossies.
What?
Have y'all ever heard that? I have a friend from England that uses that term. Oh, goodness. And all I can think to myself is, once I rule the world, that phrase will be banned. But any questions? 64 million mosquitoes. So let's come over and type in. And this whole problem, I don't know if this is true, if there's any science on this it seems to me like, from my experience, the more it rains during the summer, the more mosquitoes we have. I've never heard that you'll reach a point where the mosquitoes start dying off. So, as I said, as a general rule, let me tell you this. As a general rule, do not take scientific advice from your algebra class, okay? I remember there used to be a problem about the person on long-acting insulin, and it was hilarious, terribly wrong. The person, they would take the insulin and they'd get their blood sugar up to 220, and it'd last there for 8 hours and everything would be great. And then over the next hour, it would plummet to 40 where it would sit for the next 4 hours. I can assure you, a blood sugar of 120 is too high. A blood sugar of 40 is too low. So that problem was removed from the book, but still, it was mathematically, it was a great problem because the science behind it was so wrong. But number 13, if an object is projected upward from ground level with an initial velocity of 64 feet per second, then its height in feet after t seconds is given by s of t equals, this is number 13. Let me write down the function. Hey, there's not an x here. S of t is equal to negative 16t squared plus 64t. Find the number of seconds it will take to reach its maximum height. What is that maximum height? So we're looking for a max. I'm just making a note. We're looking for a maximum. Let's see. What letter is taking the place of x? I don't even see an x here. What letter is acting like x?
T.
T? Okay, looking in front of t squared. Do I expect this parabola to open up or down?
Down.
Down, because my a value is negative. So we expect it to open downward. If it's opening down, will we have a maximum or a minimum?
What's our max?
If it's opening downward, will we have a maximum or a minimum? And I heard a maximum y value, and it's a good thing because that's what they want us to find. Where does that maximum y value occur? At the vertex, so we have to use the vertex formula again. What's B? What number is acting as b?
64.
64. Remember that t is acting like an x. And so the number in front of the t variable is 64. And what did we say a was?
16? Oh, negative 60, sorry.
Okay. So that's a negative 64 divided by a negative 32. That gives me a positive 2. So what was x representing? They're using a t. What is that? Maybe time in seconds? So it's gonna, this little thing they're throwing up, it's only gonna go up for 2 seconds. It's not thrown up very hard. It travels upward for 2 seconds. Now they want to know the height. Once you know the first coordinate of the vertex, how do you find the second coordinate?
Oh, plug it in.
Plug it in, okay. The height after 2 seconds, we're plugging in a 2. That's negative 16 times 2 squared plus, oh, thank you, I need to switch it over. So, the height after 2 seconds, you're plugging in the 2 in place of the t. That's a 4. Negative 16 times 4 is a negative 64. Plus 128. I'm getting a total of positive 64. Was it feet? I think it was feet. So this object was thrown up from ground level. It went upward for 2 seconds. It was projected upward. It went up for 2 seconds. It got up as high as 64 feet. And then what happened after the 2 seconds? What did it start doing? It went up for 2 seconds and then it started going back down. Correct. But our answer is the height is 64.
And the S2 in the beginning?
That's just saying the height when you plug in 2,
okay.
just like this one here. Look back. I was using my function notation. Here, the number of mosquitoes with 8 inches of rain, M of 8, I plugged an 8 in for X.
Okay.
Here, I plugged a 2 in for T. The height, after 2 seconds, I plugged in the 2. That's just my function notation representation. And I need to, there's something else I need to mention. There's a problem I want to look back at. Any questions here? Make sure you understand. We just found the vertex for number 13. We'll look at this like this. The vertex, the first coordinate is 2. Hey, look at that. What should that have been? It shouldn't have been an X. What should it have been? T. It should have been T equals. The second coordinate is 64. Which one of these is the value of the function? 2 or 64? What's the y value? What's the maximum value? 64. The y value is the maximum or the minimum. Look at number 10. I have a picture drawn for us here. The figure shows the graph of a quadratic function y equals f of x. Use it to find the minimum value of y, or of f of x. Here's the picture. Well, does this thing have a maximum or minimum? It's opening upward, so is there a high point or a low point?
No.
A low point, so it's a minimum. What's the minimum value? I'll tell you right now. It's either negative 3 or it's positive 3. What is that minimum y value there?
3.
The positive 3. The positive 3. So what they're asking for, when they ask for the minimum value of y, the minimum y value, remember f of x is the same as y, 3. The value of the function is the y value, not the x value. That's what that problem is trying to emphasize here. The value of the function, the maximum or minimum, is the y value, not the x value. Any questions there?
I can see where it could be tricky.
Yes, it could.